Welcome to my YouTube channel. Today we are going to see how to design an Astable Multivibrator using Timer IC NE555. This IC is used in many applications for providing timer purpose. It is widely used in electronic circuits to provide clock signal. A clock signal consists of a square wave which will drive a microprocessor or a microcontroller or any other logical application circuits. This is the pin diagram of the timer IC. The first pin of the IC is the ground pin. The second pin of the IC is the trigger pin. And the third pin of the IC is the output pin. Here we will get the output from the IC. And the fourth pin is the reset pin. Here the fifth pin is the control voltage pin. The sixth pin is the threshold pin. The seventh pin is the discharge pin. And the last eighth pin is the VCC. Here the first pin and the eighth pin are used to supply voltage to the IC. These two pins will give power to the IC. Here in plus 5 volt has to be given in minimum, and the ground we have to give a 0 volt with respect to plus 5 volt or plus VCC. This trigger pin and the discharge pin are used in comparing this trigger pin is connected with the comparator and the discharge pin is connected to the capacitance in the external circuit, and the threshold pin is also connected to the another comparator inside the IC. This reset pin should be high to enable the IC. If this pin is low, then the IC will not turn on or it will not work. Here the output from the IC is delivered through the third pin. This is the physical view of the NE555 IC. Here this is the first pin and this is the second pin and this one is the third pin, and here it's the fourth pin. Similarly, fifth pin, sixth, seventh and eighth pin. You see a curve over here facing your eye. You have to see to the left hand side, then this will be the first pin. Okay, you see the curve over here towards your face and check, here is the first pin. From this you have to count 1, 2, 3, 4, 5, 6, 7 and 8. For all IC integrated circuit, this is the order of pin numbers. You have to do this in the way. 555 IC has 3 modes. First one is the Astable mode. In this mode, it operates as an oscillator. Okay, this oscillator is used for blinking LED or logic clock signal or tone generation or security alarm, or you can also use pulse position modulation. This mode is widely used in many applications used in 555 IC. The second mode is the Monostable mode. In this mode, the 555 IC works as a timer or missing pulse detection or frequency divider, are used in application of capacitance measurement and also to produce pulse width modulation. The third mode is the bistable mode. In this mode, the IC can be used as an flip-flop. Okay, to use this IC as an flip-flop, we should not connect any capacitor to the discharge pin and leave it free. This is the circuit diagram of a Astable Multivibrator. Here we will be seeing only about Astable Multivibrator circuit. This is the circuit diagram for the multivibrator. Okay, here you can see the reset pin. This is the supply pin. 8th pin is the VCC. you should give plus 9 volt. You can also give plus 5 volt. This is the ground pin. This pin should be grounded with respect to plus VCC. And the fourth pin is the reset pin. You have to connect the reset pin to a high level, otherwise the IC will not turn on. These are the threshold and trigger pins. These two pins are short circuited and connected to the capacitor. And the seventh one is the discharge pin. Here the capacitor discharges through the path. Okay, this forms the RC network and used in discharging purpose. Okay, then the third one is the output pin. Here the square pulse generated will be fed into the LED and the LED will start blinking. Let's move into the operation. In 555 IC, to make this as an astable mode, we need to short circuit the pin 2 and 6. This will make the IC to trigger itself and run in an oscillator mode. During each cycle, the capacitor C charges through the resistance R1 and R2. You connect a battery to a 9 volt and a ground. Then the capacitor over here, 1 microfarad capacitor, will charge us through the resistance R1 and R2 and discharges through the resistance R2 into the discharge pin of the 555 IC. Okay, we have some design formulas for designing a Astable multivibrator. The turn on time, T on time of the pulse will be 2 by 3 of VCC. The voltage in the second and sixth pin will be 2 by 3rd into VCC. If it's 9 volt, then 2 by 3rd of VCC will be 6 volt. And the capacitor discharges up to a voltage of 1 by 3 VCC. If it is 9 volt, then 1 by 3 of VCC will be 3 volt, then the discharge voltage will be 3 volt. Okay, then the capacitor will charge up to 6 volt and discharge up to 3 volt. This is the another formula. T of time, T2 is T of time will be 0.693 R2 into C. This R2 is the resistance and C is the capacitance. Similarly here the T on is the on time equal to 0.693 R1 plus R2 into C. R1 and R2 are the resistances over here and C is the capacitance 1 microfarad. This is the review of formulas. We know that T on period is equal to 0.693 into R1 plus R2 into C and T off is equal to 0.693 into R2 into C. We know T is equal to total time period. T is equal to T on plus T off. When getting this added, we can make 0.693 as common and we can formulate this equation as 0.693 into R1 plus 2R2 into C. We all know the formula, frequency is equal to 1 by T and we are substituting the T over here and getting a value of 1.44 divided by R1 plus R2 into C. Now we are choosing a resistance R1 of 1 kilo ohm and R2 of 470 kilo ohm and capacitance of 1 microfarad. We know that T on is equal to 0.693 R1 plus R2 into C. Now we are substituting the resistance R1, R2 and C in the equation. We know R1 is equal to 1 kilo ohm, that is nothing, 1000 ohms, and R2 is equal to 4,70,000 ohms, which is 470 kilo ohm is converted into ohms, and capacitance is 1 microfarad. We should convert into farad, so 1 into 10 power minus 6 farad. Micro stands for 10 power minus 6. Okay, then we are calculating this equation and finding that it is t on time is equal to 0.326403 seconds. That is, the on time of the square wave is 0.326403 second. Then we need to calculate the off time. Here it is the off time. Formula 0 t off is equal to 0.693 into R2 into C. Substituting R2 and C, we get 0.32571 seconds. The total time period t on t is equal to t on plus t off. Adding these two values, we get 0.652113 seconds. Then finding the frequency, we know f is equal to 1 by t and we get a frequency of 1.5335 Hz. Okay, when we use a resistance of 1 kilo ohm and resistance of R2 of 470 kilo ohm and capacitance of 1 microfarad, we can generate a frequency of 1.533 Hz. If we want to generate a different frequency of 10 kHz or some other thing, you can reversely calculate this in a reverse order and find the resistance and capacitance. Then we can substitute the resistance and capacitance in the equation and get a 10 kHz waveform. There are several online calculators to find these frequencies from the values of R1, R2 and C. You can browse the internet and find these calculators, online calculators. Okay, now move to the hands-on session. The components required are resistor of 1 kilo ohm and a 470 kilo ohm resistance, resistor of 1 kilo ohm, we need a 1 microfarad capacitor, NE555 IC and an LED and connecting wires. Now let's move to the simulation. This is the 555 IC and we have connected this circuit diagram as shown in the previous circuit. This 555 IC is connected in Astable Multivibrator mode. This graph shows the voltage across the discharge pin and this graph shows the voltage across the trigger and threshold pin. Now let's start simulating the circuit. At the instant, the capacitor first charges to a value of 2 by 3 VCC, which is nothing but 6 volt. You can see it's slowly charging to a value of 6 volt. Once it gets fully charged, it starts to discharge through the resistor R2 into the discharge pin and leaves the IC till it gets a voltage of 3 volt, which is 1 by 3 VCC. After it reaches 1 by 3 VCC, which is 3 volt, it starts charging through this path of 1 kilo ohm, 470 kilo ohm and gets charged to a value of 6 volt. After 6 volt, it starts to discharge through the discharge pin. This operation continuously occurs and makes this LED to blink. Now the LED starts glowing. When this voltage reaches 6 volt, the LED will stops glowing. See, it stops glowing. Now the capacitor is discharging. After it gets discharged, now the capacitor starts to charge. During the charge cycle of the capacitor, LED will light up. During the discharge cycle of the capacitor, LED gets switched off You can see the discharge waveform over here. And now the capacitor starts to charge. You can see the charging waveform over here. This operation continues and makes the LED blink continuously in a predetermined frequency as per the above calculation set, and generates a square waveform in the output pin, which is the third pin of the IC. This graph shows the output terminal of the 555 IC. You can see the clock signal, which is the square form, is generated from the third pin of the 555 IC. When the signal is high, the LED will glow, and when the signal is low, the LED will stop glowing. Check when it is high, it starts glowing. Its output voltage is 8.993, which is equivalent to the VCC voltage, the battery voltage. When it is low, the output voltage is 0 volt. The clock signal is used in many digital applications to drive the logical circuits. So this IC is called as a timer IC. Now we start the practical session. This is the NE555 IC. You can see a notch over here. To the left hand side of this notch, this is the first pin, and this is the second pin, third and the fourth pin. Then this is the fifth pin, sixth, seventh and eighth pin. This is the order number of the pins in. Now let me start building the Astable Multivibrator using 555. First we ground the first pin and connect the fourth and eighth. Connect the first pin. Then connect the eighth pin to the upper end of the breadboard. Connect the fourth pin to the plus 9 volt supply. Now we are going to connect the resistance R1, R2 and capacitance C all in series with the plus 9 volt and R1, R2 and C to the ground. Let's make this connection. Then take the resistance of 470 kilo ohm and connect one terminal with the resistance. Here the capacitance, this terminal is negative terminal. Connect the positive terminal of the capacitance with the resistance and ground the negative terminal to the breadboard ground. Now we are going to short circuit the second and sixth pin. This is the second pin and this is the sixth pin. We are going to short circuit the second and sixth. Now we are going to connect the 7th pin. After connecting this, from the resistor and the capacitor terminals from this end, we are going to connect it to the 2nd or 6th pin. Use a Now we are moving to the output side. Connect a LED in series with a 1 kilo ohm resistor. Now connect the resistance to the LED and then now take a battery of 9 volt and connect the positive terminal of the battery to the upper end of the breadboard. Then connect the negative terminal of the battery to the lower end of the breadboard. Thank you for watching the video.